welcome to the 7.2 notes. I will say right now, you guys are going to want a calculator with you. So pause this video, make sure you have a calculator. It doesn't have to be one of these, but you need a calculator. You can try and do some of this in your head, but you're not going to be able to do all of it. You're going to need a calculator for it. So what we're talking about today is interpreting quadratics. So when we're talking about the vertex, we did the vertex in 7.1, but we didn't actually talk about what it means. The vertex represents a maximum or a minimum value. Because as you draw your parabola or your U-shaped graph, which is called a parabola, that vertex is either at the very bottom or at the very top in the middle of the parabola. So it is always either the highest or the lowest. And remember that the formula for a vertex is negative b over 2a, comma, y. And the reason why I'm just saying y is because when you get this number, you plug it in to find this one. Okay? The y-intercept of the graph represents the initial value or starting height. So it really is the initial value, but on most of our problems, we're actually talking about height. So starting height is one way of thinking of it. And then just keep in mind, you've got to read your labels so that you know what it's talking about. The x value is almost always going to be time, and the y value is almost always going to be height or distance. Okay? And then we're also going to talk about, yes, these two, but then we're going to talk about what solutions actually mean. If you're trying to tell something is a solution on a graph, then you want to see if the point is on the curve / line. So if I want to know if something is a solution to this one, I'm going to go find the point and see if it's on this thing. Okay, on that solid line. Hey, thanks.
I'm sorry.
You're good. You're fine, you can set it right there. If it is in an equation, you plug in the x value, and you're just going to want to see if the y value matches. Boom. Okay, and we're going to go over that here in just a second, but that is the bulk of what you need to know for today. The vertex has to be a max or a min. The y-intercept is the initial value. Make sure you read your labels, and if you want to tell something's a point, either see if it's on the line or plug in the x value to see if your answer matches the y value. Let's talk about Devin jumping off of a diving board in example 1. So Devin jumps off of a 12-foot diving board. His height, h, this is like the y value, is t seconds after he leaves the board is represented by this equation. So the y value is turning into h and the x value is turning into t. It's just using different letters, okay? And then it gives you his equation right here. Awesome. When it asks you for the maximum height, that means that you're going to use that negative b over 2a formula because that goes with a max or a min, okay? When you find this, the negative b over 2a one is going to be your time. You have to plug it back in to find your height, okay? So this is going to be the time. Okay, so negative b, remember that a is the first number, b is the middle number, c is the last one. They just go in order alphabetically. B is 20. A is negative 16. So I'm just replacing the numbers where they go, and this really becomes negative 20 over negative 32. Now, this is not going to be a super nice number. It's going to be a decimal. That's why I said you needed to have a calculator. And there you go. It's 0.625. And this was T. T represents seconds. Then you take that number and you plug it back in for T. Actually, we're not even going to write it down. We're just going to plug it in. So start with the negative 16. And then instead of T, you're going to put 0.625 squared plus 20. And then we got another T, so 0.625 plus 12. 18.25 feet. And how did I know it was feet? Because this is my H value, which is in feet. It says it in the problem. Read your labels, guys. How high is the diving board? The diving board is where he was jumping off of. So yes, it says in the problem it's 12 feet, and it's the y-intercept at the end. And then all you have to do for part C is the same thing we did here, but you're plugging in 2.5. So I'm using this equation again, but I'm changing the number in the parentheses to 2.5. He's negative 38 feet. That means he's underwater, by the way. And maybe he's like scuba diving or something. Because 38 feet underwater is quite a bit. Okay, and then I'm going to briefly go over this last part, but this is going to be a little bit more just something that you type in. So what you're going to do is take the x value and plug it into the equation. So I'm replacing these x's with 3. And then I'm going to type that into my calculator. That's 22. What you need to do is check. Are these two numbers the same? Nope. So that one's not a solution. Then you do the same thing, but you plug in negative 2. Negative 2 instead of 3. So I'm just going to go back and change the number in my parentheses to negative 2. And that gives me negative 3. Do these match? Yes. And then do the same thing, but with negative 1. Do these numbers match? Nope. And then for the graph, you just want to look and see, are those points on the line? Negative 3, negative 4. Negative 3, negative 4.
Can I please get the hand around Matthew Carton, Rainey Lewis, and Adrian Seals to the office, please?
Negative 4, negative 3. Yep. And negative 3, negative 2 is right here. That's not on the line, so that one's a no.